same concept goes on here. We have 0, 1, 0, 1, 0, 1, double 0, double 1, double 0, double 1, 4 zeros, 4 ones, 8 zeros, 8 ones, and so on. I've just abbreviated this, or, cross-sectioned it, so I'm only finding, the first so many addresses and showing you where if we place all ones in this structure, we get a 255. 255. But that's not a broadcast. You'll have learnt that all ones in the host portion is in fact broadcast. So that's where we'd have to have a 1 in this host bit as well. So that's important to understand that our host address has to basically recycle through again. What I mean by that, in our first case we see this is equal to 0. And therefore, for our first network that we found, which was 150.15.0.0, this was subnet 0, our very first address, we couldn't use that one. So we say we don't allow that as an address for a particular host or a router's interface. That is not a possibility. Just like all the ones, the broadcast address is not used for host addressing. It's a reserved address to broadcast. So what we look at is this one here, which gives a value of 1. The 1 is under here. So in our subnet 0, it would typically be 150.15.0.1. Then it would just count up. Dot 2, dot 3, dot 4. You see there's a 1 under the 4. Dot 5, 4 and a 1. Dot 6, dot 7, and so on. And we get all out to all ones here. Dot 255. But that wouldn't be our broadcast because we've got a 0 still over here representing not all ones yet. So we don't go and put a 1 there. We actually start again and we have an address simply like this, where in that subnet 0 we'd have a point where we reach this as a value. And it may not look like an address, but it in fact is an address. So that 1 is indicated here. The 1 from placing a 1 there is shown as 1 here. And then this is all zeroed again, we start again. So then it goes 1.1, 1.2, 1.3 as we go through here. 1.3, 1.4, 1.5, all the way up to 1.254. So when we get to 1.254, we've nearly reached broadcast. Let's just be saying there's a 1 here, all these are 1s except that's a 0. So that's the last possible address in our subnet 0, our first subnet. Hopefully that makes a little bit of sense to you there, that when I get to 1.255, I'm broadcasting because I'm placing a 1 here and all these are 1s. So that's the broadcast address for subnet 0, the first subnet. We move on to the next subnet, so we're going to look at the subnet 1 or the second subnet. Subnet 1 or the second subnet. We find that we have in this position no longer a 0, we have a 2. A 2. And this is because we had all zeros there and then the first value we found was under that 2. So we've got 150.15.2.0 and we go through and find the address range simply by going 2.1, that would be this one. We can't have 2.0 as an address, that's actually the network, the road, the second subnet, subnet 1. And we just go through. Now we would get all the way up to 255, which is shown here, all ones, but it's not the broadcast because then we move on and we've got a 1 here, and that 1 would actually come inside this number here and become 3.0. So putting a 1 there to go through the next lot of network, the next address range in the network, by putting a 1 in that position, the 1 goes on top of the 2 to make 3. This is the tricky part. Remember, whenever you've got a host bit inside the same area as network bits, the host value must add on to the network part. So that's why 2 becomes 3, then we go 3.0, and that's actually an address for a host, PC, printer, whatever. Then it goes 3.1, all the way up until it goes to 3.254. We can't go and use 3.255 because 3, this field 1 here, going on to the 2 is 3, having all those as 1 except for the last one, keep that 0, and that would give me that value there. So that's the last address of the second subnet, or subnet 1. So if I go and put a 1 in every position, it would be 3.255. And that is logical because after 3.255, our next subnet is 4. This changes from 2 to 4. So if we come back a little bit, you'll remember that we go from 2 to 4 to 6 to 8. So the very last number before this network, so we look at this network, the very last number would be 150.15.5.255. You see that that's the very last number before it changes to 6. I've exhausted this area. I've found 5 here, so the only way to go up is to 6. So that's the broadcast of the 150.15.4.0 network. That's the broadcast. So 1 before that would be the last address possible on this network, which would be 5.254. Finding these addresses when we're borrowing bits across our octets can be a bit tricky. Just note that jump. Class B is a little bit more sophisticated, if you like, than Class C. So there's little tricks, there's little rules where you can see that if I know the network number, the last number before the new network is the broadcast. So what's the last number before it changes to 150.15.8? It would be the broadcast for this network, therefore. The broadcast for this network would be 150.15.7, can't be 8, .255. That's the broadcast address of this network. And 1 before that would be not broadcast, it would be the last address I could use on a host. So there's a lot to sort of work through with this. SubNet calculator is a good idea, so if you're going to do practice, make sure you go and put the same model in your SubNet calculator and you can see the whole range of addresses. It's the range of addresses that will clearly show you that there's no gaps between each step in the network. So, you know, back here we said it goes 0.1 as the first address. And it goes all the way till it reaches 1.255 before it changes to 2. But you can't use 1.255, that's actually a broadcast address. So it's going to be 1.254 as the very last address in the range. We understand that we've got, in fact, not 8 bits but 9 host bits as our address range. And the rule there is that it's just basically 2 to the power of 9 minus 2 equals the total number of usable host addresses, which is 510. 2 to the 9 is 512. Take away 2, because we can't use, as we showed before, we can't use this one. That's not allowed. And we can't use this one. So there's always 2 addresses you can't use in the system. The zeros, which is all the way there, sorry, and all the ones. So that's finding our Class B environment, using our number of bits required, designating the hosts, designating also the networks through this step here. Have a go.